Hi, welcome to our group presentation, CAT260. We will begin. I'm Ben, and I will be taking the first portion, followed by Rob and then Michael. First, we will demonstrate how to build a function. There are 7 steps in building a function. The first step is to clearly define the problem, and this includes what exactly must the function do, what inputs are needed, and the output to be returned, and the validation rules to be enforced. From our end user story, we took our player and he's going through a mansion and he's collecting items that he puts on his tool belt while he's going through the mansion. So he has 3 inputs: the number of items, the weight of each items, and the current weight of the total belt before and after the additional items are added. The output is expected to be 20 pounds or less. If it goes over 20 pounds, the function will give an error. And step 2 here, we have created the test matrix. And as you see on the left side of the screen, we have the items that goes from hammer to slingshot and so forth, and their weight and the number of items. And so as you go through the test will be valid if it's if it's less than 20 pounds, but it will be invalid if it's more than 25 pounds. And so the boundary is between 0 and 20.
So the third part is to clearly outline the solution in a test algorithm. And that's easiest done by using pseudocode rather than trying to go straight to writing the final code. So if you outline the problem, which is we need to have a function which at any time during the game can calculate the total weight of the belt and make sure that it lies within 0 to 20 pounds. And once we write the pseudocode, we can then set up the spreadsheet and add some numbers in to test that code to make sure that our output will be correct. Here we have another function which will then determine whether we can pick an item up or not. So we use we have 3 values. We need to know the current weight of the tool belt, and then we need to know how much weight we're adding. So we have the items on the left side, and then we have the quantity of each one of those items and the weight of each one of those items. So then we set up a test. We have 6 tests here. We set up 1 valid test, which we expect to be true. The total weight of the belt is 1. We add 2 pounds. 3 is within the boundaries. Then we have 3 invalid tests, which we expect to be false. And then we have 2 tests, the boundary tests. One tests the lower limit, and the second one tests the upper limit.
Okay, then moving on, the 5th step consists of translating the pseudocode or the algorithm into actual Java code. And if we switch to my screen, we can see some example code of that where we took the pseudocode and we took what was basically written as plain English and translated it into functional and working Java code, where we take the total belt weight and we add to it the individual item weight and the quantity, and we check to make sure that if it is less than 0, or we check to see if it is greater than 20. If it is, then it will return false. We then check to make sure that the quantity of items being attempted to be picked up is greater than 0 but not greater than 2. And if either of those end up being the case, then it returns false. And if it passes all of those requirements, then it ends up returning true, and the user is allowed to pick up the item. The sixth step is to run the test cases against this code to make sure that works. And so for that, we take from the test matrices that we created, we took the different values for the valid and the invalid, and then also for the boundaries, and we created the test file, and you then run the test file to what that is supposed to run. Of course, it doesn't want to run now. There we go. Okay, you run the test, and it creates and it checks to make sure, and all the tests pass, which means that we correctly translated our algorithm and it is working properly. The final step is to commit your changes to Git, and then you push them to the remote repository. And that concludes the 7 steps that are needed for creating a function.
So the next item that we'd like to show are the selection statements that Java offers. So we'll show a piece of code that displays an if statement.
Okay.
And here we have the tool belt control. So with this if statement, the first if statement, we are determining whether the total weight of the tool belt is within the boundaries between 0 and 20. So using the 3 parameters passed to this function, take item, we have the item weight in the middle times the quantity plus the tool belt weight. And if that is less than 0, which would be your tool belt weight cannot be less than 0, or the total weight is greater than 20, we return a value of false back to the function that called this function.
The second if statement shows that if the quantity is less than or equals to 0, or if the quantity is larger than 2, it will return false. So if you're looking through our test matrix, we could go through, we have several items like hammers and so forth. If the player picks up more than 2, it will return false. So in the select statement, the iteration that comes with it goes twice. So both have to be true in order for the statement to be true. If either one is false or both is false, then the function will return false.
Okay, and now moving on to an example of some if statements that I have written. If we switch here to the item shop control, in this we're checking whether or not it is possible to craft an item, and every item will have a set of needed resources in order to make it, and so the user will be selecting what resources they want to use to try to craft it, and this will go through and check and see if the check to see if the required resources are given from the resources that the user passed in. And then also they check to see if the quantity also matches in the if statement. And then following this, we created a test, some test code to verify it. And so for mine, the various test cases that I made for the program can be seen here. And if this is ran, then it also passes all tests as is expected. Continuing on, we are next supposed to explain the scope and lifespan of variables. And so for the example that we're going to use demonstrating this, we are going to use our main menu view program. And in it, we have declared multiple variables. We have a top-level variable that exists at the very top level of the class here called menu. And this variable is able to be called within all functions that are contained within the main menu view class. We also have variables that are contained at lower levels, such as this character called selection, which is only able to be seen within the display menu function. And then going on even further, we have the input variable here within the do while loop, which can only be seen within the actual loop. Once the loop ends, the variable will end up disappearing because it has left the block of code that is visible in.
So the different Java has many different levels of control, and one of those is being able to control when a variable is or is not used, and one is by only allowing it to be used, the scope of the variable being allowed to use where it's defined, and that often helps protect and make sure that the types and proper values for variables are being passed by not allowing access by other functions or other classes. So when you leave a set of brackets or a scope, then the variable is then no longer used and no longer defined.
Okay. We will now do pass by values and pass by reference. As we can see here, there's a public class called pass example, and so this is an example to show how to pass by value. And so passing by values are normally used through functions. They use primitive, and those are passed and copied through the memory, and it passed through a corresponding parameters. So making copy in memory of the actual parameter value when you're using some parameters to compute computation. And so for our example here is the first test. So we are passing the value, the integer, which is 5, and when it comes out, it's coming out as test 1 is equals to 10, but when we pass it, we said it will equals 5. And so when the test comes out, it does not follow test 1 is equals to 10. It prints the pass by value, which is 5.
So passing by reference is different in that a variable references an object rather than actually being equal to that object. It is so if the value of that object changes, then so does the value of the variable that it references. And instead of being a constant value.
Yeah, a good example of this we can see with this string variable called test2, which has the value of test. And when it is passed to a function and modified within that function, as is here, then when the function ends, if that value is printed out, then it will end up printing the value that was changed to. So even though it was initialized with the value of test, since it is changed in the function, it will instead print out test2. And so hopefully that serves as a good example of what the difference is between pass by value and pass by reference. And we thank you for listening to our presentation and hope that you have enjoyed it.